So in MATLAB, it's really easy. You find x as FFT of little x. Remember, MATLAB is capitalization matters. And if you want to go in the opposite way, little x is equal to the inverse FFT of big X. So I cringe a little time every time I write FFT because it's not FFT, it should be DFT, but that's the algorithm that they use. So just as an example of what we just did, let little x be equal to zeros, 1 row, 5 columns, and then we'll set x of 1 to 1. So at this point, x is equal to 1, 0, 0, 0, 0. And then our capital X is equal to FFT of our little x. And then we can stem that. If we want to stem plot it, we have to create our index vector. Now I could say n, but it's better form to write k if we're talking about the frequency domain. K is equal to 0, 4. And then we'll stem our k. And here's the trick we have to remember. If we try to stem x directly, we'll get an error thrown. And why is that, Walt?
I'm not sure.
It's because it has to do with the domain. Is x real or complex?
I'm not sure.
Okay, so the FFT, the DFT of a real sequence is complex. And so this will throw an error because you can't plot in 2 dimensions a real variable against a complex variable. So we have to take its absolute or its angle, and then this will plot what we found in the previous graph, which is that. So this is, we're plotting the absolute of x of k versus k. And in general, if you plotted something kind of random, you might end up with something that looks like this and realize that there's symmetry here. And then this is the one that has no corresponding thing that's added that would be out at 2 pi. All right, I think I've kept you over by 2 minutes, but that's everything. If you've got questions, feel free to stay on and we'll talk about them. Otherwise, you're free to go.
So I have one quick question, just to clarify what we did.
Shoot.
So the FFT is that something we're only doing like in MATLAB computationally? What we did by hand, that wasn't the FFT, right?
What you did in the last lesson was the DTFT. And then what you did this lesson over here, that is the DFT. The FFT is just an algorithm to compute the DFT in a very efficient way. Does that answer your question or not quite?
Yes, sir. Thank you.
Sure. Yeah, so big picture is the FFT is just an efficient algorithm used to compute the DFT. So I'll use the correct nomenclature in this class, which is we'll take the DFT of the signal. And then the DFT only exists because the FFT is a computationally efficient way to compute it as an approximation to the DTFT, which is the thing that has the most, I think, intuition. And it explains why we zero pad signals a lot in the time domain so that its DFT, which is easily computed, closely matches its DTFT.